In this video, we'll be learning how to write a quadratic function in standard form. Then once it's in standard form, we'll be able to identify its vertex and sketch its graph. Let's work through some examples. In example A, we have the function f of x equals 2x squared plus 12x plus 16. Right now, the quadratic function is written in the form ax squared plus bx plus c. Our goal is to rewrite this in standard form, which is a times x minus h squared plus k. In order to rewrite our quadratic function in standard form, we'll need to follow a few steps. Our first step is to factor a from all terms. The a that we're referring to is the coefficient of the x squared, or the number that's being multiplied to the x squared. In this case, it's 2. So taking our polynomial and factoring 2 from all of our terms, we have 2 times x squared. If I have 12x and I factor out 2, I'm left with 6x. And then lastly, if I have 16 and I factor out a 2, I'm left with 8. Whenever we factor a number out like 2, what we want to do is we want to take each of our terms and we want to divide by that number. So 2x squared divided by 2 gives me the x squared, 12x divided by 2 gives me 6x, and 16 divided by 2 gives me 8. You can always check that you factored things correctly by taking the number out in front and redistributing it to each term inside the parentheses. When you do that, it should match up with the original polynomial that you started off with. Once we factored the a from all of our terms, our next step is to complete the square. So let's take our function and rewrite what we have. We have 2 times x squared plus 6x, but before I write the plus 8, I'm going to leave myself a little bit of space and then close the parentheses. Now, to complete the square, we want to look at x squared plus 6x, and we want to think to ourselves, what can I add to this so that I can factor the result as a square? Remember that to complete the square, you want to look at the number in front of the x, the 6 here. You want to divide that by 2 and then square the result. So 6 divided by 2 gives us 3, and 3 squared gives us 9. So if we add 9 to this, the resulting polynomial can be factored as a square. Now, there's one thing we have to be careful about. We can't just add 9 to our function because that will change our function. So whatever we do, we need to balance things out so we don't actually change our function. So if I add 9 to this, at the same time, I need to also subtract 9. The operations of adding 9 and subtracting 9 will cancel out, so I haven't changed my function at all. But by adding 9, what this will allow me to do is it'll allow me to factor the x squared plus 6x plus 9 as a square. So factoring that portion, we have f of x equals 2 times, instead of x squared plus 6x plus 9, we can rewrite this as x plus 3 squared. And then we still have minus 9 and a plus 8 at the end. Once we've completed the squared and we factored, our next step is to simplify and distribute. When I say simplify, what that means is I want to combine the negative 9 and the plus 8 together. This gives me f of x equals 2 times x plus 3 squared minus 9 plus 8 gives me negative 1. Next, we want to distribute. Our 2 is being multiplied to all of this stuff. Inside these outer parentheses, there are 2 terms inside, the x plus 3 squared and the negative 1. So we're going to take the 2, distribute it to the x plus 3 squared, distribute it to the negative 1. So in the end, we have f of x equals 2 times x plus 3 squared, and then 2 times negative 1 gives me negative 2 at the end. So now we've rewritten our quadratic function in standard form. Next, let's try to identify where the vertex is. When our quadratic is written in standard form, a times x minus h squared plus k, the vertex is h comma k. The x-coordinate of the vertex is the number that's being subtracted from the x. The y-coordinate of the vertex is the number that's added at the end. When we look at the quadratic function that we have in our example here, we have 2 times x plus 3 squared minus 2. Right now, we don't have x minus a number. Instead, we have x plus 3. But remember, we can think about this as x minus negative 3. By thinking about it this way, we see that there's a negative 3 that's being subtracted from the x. So, for this quadratic function, the x-coordinate of the vertex is negative 3. The y-coordinate of the vertex is just a number at the end. In this case, the number at the end is a negative 2. So our vertex is negative 3 comma negative 2. So once your quadratic function is in standard form, if you want to find the x-coordinate of the vertex, you want to look at the number that's with the x inside the square and flip the sign. Here we had an x plus 3, flipping the sign, we get a negative 3. And for the y-coordinate of the vertex, all we have to do is take the number that's at the end. Now, one last thing we want to do here is to graph this quadratic function. Because we've written this quadratic function in standard form, we can think of our function as graph transformations applied to the x squared function. Specifically, the plus 3 inside the square corresponds to a shift to the left 3 units. The multiplication by 2 outside of the square corresponds to a vertical scale by a factor of 2. And then lastly, the minus 2 at the end corresponds with a shift down 2 units. Let's use these graph transformations to help us draw the graph. First, let's start off by drawing the x squared function, which looks something like this. Our first transformation is shift to the left 3 units. So taking our red graph, moving it to the left 3, we get this blue graph. This would be x plus 3 squared. Our next step is to do a vertical scale by a factor of 2. So imagine drawing your blue graph on a piece of slime and stretching that piece of slime so that it's twice as tall as it used to be. And that will give us this green graph. This would be 2 times x plus 3 squared. And then our last step is to take that green graph and shift it down 2 units. That's going to give us something that looks like this. So in purple, this is our function f of x equals 2 times x plus 3 squared minus 2. So by writing our quadratic function in standard form, we can realize it as graph transformations being applied to the x squared function. And that makes the graphing process much easier. Let's do a couple more examples. In example B, we have the function g of x equals negative 1/2 x squared plus x plus 2. Remember, we want to write this in standard form, then we want to identify the vertex and draw a sketch of the graph. Our first step in writing this in standard form is to factor the number in front of the x squared from all of our terms. In this case, it's going to be that negative 1/2. So our function is g of x. Pulling out that negative 1/2, we want to think about what's left. When we factor any number from a polynomial, what we want to do is we want to take each term and divide by the number that we're factoring. So we have negative 1/2 x squared. If we divide by negative 1/2, then we're just left with x squared. Next, we have x here. Take x, divide that by negative 1/2, we're going to get negative 2x. And then lastly, we have 2. Divide that by negative 1/2, that gives us negative 4. Remember that if you have trouble dividing by a fraction, you can always think about division as multiplying by the reciprocal. So dividing by negative 1/2 is the same as multiplying by negative 2. That's why when I took x and I divided by negative 1/2, we ended up with negative 2x. 2, divide that by negative 1/2, that gives us negative 4. And you can also check that you've done things correctly by taking the negative 1/2 and redistributing it to each of the terms inside the parentheses. If you were to do that, you should check that you end up with your original polynomial. Now that we've factored the number in front of the x squared, our next step is to complete the square. So let's copy down our polynomial again. We have g of x equals negative 1/2 times x squared minus 2x. I'm going to leave myself a little bit of space before I write the minus 4 at the end. So now what we want to do is complete the square on the x squared minus 2x. we want to add a number to this so that we can factor it as a square. Remember that to complete the square, we want to take the number in front of the x, this -2 here. We want to divide that by 2 and square the result. -2 divided by 2 is -1, and -1 squared is +1. So we want to add 1 to this. Now, if I just add 1, this changes my function. I'm no longer working with the function that I started off with. So to balance things out, we also need to subtract 1. The +1 and the -1 cancel each other out, so I'm not changing my function at all. But by adding 1, this allows me to factor these terms here as a square. And that's our next step. Our function g of x is -1/2 times x squared minus 2x plus 1. That can be factored as x minus 1 squared. And then we still have -1 and -4 at the end. Our next step is to simplify by combining the -1 and the -4 and then distribute the -1/2 out in front. So our function is g of x equals -1/2 times x minus 1 squared. Combining the -1 and -4, that gives me -5. And the last thing that we'll do is we'll take that -1/2 and distribute it inside the parentheses, multiply it to each of our terms inside. This gives us g of x equals -1/2 times x minus 1 squared, and then -1/2 times -5 gives me +5/2. And this here is our quadratic function in standard form. Now that it's in standard form, we can read off what the vertex is. Remember that the x-coordinate of the vertex is the opposite of the number that's with the x inside the square. So there's a -1 with the x here, so the x-coordinate of our vertex is +1. And then the y-coordinate of the vertex is the number at the end. In this case, it's 5/2. So our vertex is 1, 5/2. Next, we'll draw a sketch of the graph of this function. Remember that by writing our quadratic in standard form, we can think about our function as graph transformations applied onto the x squared function. So we'll start by drawing the graph of the x squared function. Now our first graph transformation is a horizontal shift. Looking inside the square, we see an x minus 1 here, so that corresponds with a shift to the right 1 unit. So in blue, this is x minus 1 squared. Our next graph transformation is this multiplication by -1/2, which is a vertical scale by a factor of -1/2. This means we want to take every point on our blue graph and multiply the y-coordinate by -1/2. The effect of it is this. The fact that it's negative means we're flipping our graph across the x-axis, but then the 1/2 means we're compressing our graph so that it's half as tall as it used to be. Combining those two things together, we get a graph that looks something like this. So in green, this is -1/2 times x minus 1 squared. And then our last graph transformation is to shift up by 5/2 units. 5/2 is the same as 2.5. So move that green graph up 2.5 units, and we end up with something like this. This is g of x equals -1/2 times x minus 1 squared plus 5/2. So that's how we use the standard form to help us draw the graph of our function. Let's work through one last example. In example C, we have the function h of x equals 3x squared plus 12x plus 13. Remember, our first step is to factor the number in front of the x squared from all of our terms. When we factor out a 3 from our polynomial, to figure out what's remaining, we want to divide each of our terms here by 3. So our polynomial is h of x equals 3 times 3x squared divided by 3 leaves me with just x squared. Next, 12x divided by 3 leaves me with 4x. And then lastly, 13 divided by 3. Well, that's not a whole number, so we'll just leave it as 13/3. Remember that if you want to check if you factor things correctly, take the 3, redistribute it to each of your terms, and see if it matches up with your original polynomial. Now that we're done with our first step, next we want to complete the square. So rewrite our polynomial h of x equals 3 times x squared plus 4x, and then leave yourself a little bit of space before writing the 13 thirds at the end. Now to complete the square, we want to look at the x squared plus 4x and we want to figure out what number we can add to the end here so that we can factor it as a square. The process is to look at the number in front of the x, the 4 here, divide that by 2 and square the result. So 4 divided by 2 gives us 2, and then 2 squared gives us 4. So by adding 4 here, we'll be able to factor it as a square. But we can't just add 4 to this function because that's going to change my function. To balance things out, we also need to subtract 4. Next, we want to factor the x squared plus 4x plus 4. That portion factors as x plus 2 squared. So our function h of x is 3 times x plus 2 squared, and then we still have a minus 4 and the plus 13 thirds at the end. Our next step is to simplify by combining the negative 4 and the plus 13 thirds together, and then we'll distribute the 3. Our function h of x is equal to 3 times x plus 2 squared. Now, if I want to combine the negative 4 with the 13 thirds, we need to get a common denominator. We can rewrite the negative 4 as negative 12 over 3, and then plus 13 thirds. Now that they have a common denominator, we can combine these two fractions together to get positive 1/3. So our function h of x is 3 times x plus 2 squared plus 1/3. Lastly, we just have to distribute the 3. So take the 3, distribute it to the first term, distribute it to the second term. We get h of x equals 3 times x plus 2 squared, and then 3 times 1/3 gives me just 1 at the end. So our function in standard form is h of x equals 3 times x plus 2 squared plus 1. Now that it's in standard form, we can read off the vertex. To get the x-coordinate of the vertex, we want to flip the sign of the number that's with the x. So since there's a plus 2 with the x-coordinate of our vertex is negative 2. The y-coordinate of the vertex is just a number at the end, which is positive 1. So our vertex is negative 2, comma 1. Lastly, to graph this function, we want to think about it as graph transformations applied to the x-squared function. Start by drawing the x-squared function. Our first graph transformation is a horizontal shift. Because we have x plus 2 inside the square, this is a shift to the left 2 units. So take our red graph, move that over 2 units, and we get something like this. This is x plus 2 squared. Next, we have a 3 multiplied outside the square, which means we have a vertical scale by a factor of 3. So we want to take our blue graph and stretch it so that it's 3 times as tall as what it used to be. So this here is 3 times x plus 2 squared. And then our last graph transformation is this plus 1 at the end. Basically, we want to take our green graph, move it up 1 unit to get our final result. So in purple, this is our function h of x equals 3 times x plus 2 squared plus 1. So in this video, we learned how to write a quadratic function in standard form. And once it's in standard form, we can identify the vertex of the parabola, and we can use it to help us draw the graph of the function.